Hi, today let's discuss about slices in Go. In Go, slices are similar to arrays, but the size is not defined as part of the data type. What that means is when you define a slice, unlike an array, you will not indicate the size of the structure that you're creating. So in this case, this is all the elements of this slice are integer type. So I have defined the slice or declared the slice like this. And initializing slice is just like do it for the array with the same caveat that there is no size fixed. So on accessing the slice, accessing the elements of the slice is similar to what you do in case of array. You use the index starting from 0 to identify the specific element that you're trying to retrieve. And likewise, you can also initialize individual elements with the same notation like this. And if you try to access or read or write a specific index position which is outside the length and capacity of this slice, it is going to be a it's going to be a runtime error. In case of array, it is a compile time error, but in case of slice, it's going to be a runtime error. And to get the length and capacity of the slice, use the same methods, len and cap. And to loop through the slice, you can either use the regular for loop with the counter variable initialized from 0 to length of the slice and incrementing one at a time, and using that counter variable as index. The other way to do it is using a range operator, which is used with a for loop. It returns the key and value. In other words, index and value of the slice. And you can use those variables to get the index and value. Okay, let's give a run and see. As you can see, it printed 500. There is the value in the index position 2. And then here it printed the length and capacity, which is 4 and 4. So in case of slice, the capacity by default will be the same as what it depends on the elements that we have given during the initialization. And there is a way to set a different capacity by using make keyword, which we'll cover in a little bit. And then we are printing all the elements of the slice using a for loop. And then this is using for loop with range. So it is the same thing, but it comes with the convenience of not having to increment and check the condition of the counter variable. Okay, so just like with any variable, we can also declare slice in multiple flavors. One is declaring and initializing a separate line. You can also initialize in the same line as you declared, like here, and you can use the shorthand notation to infer the data type. And you can also use make keyword, which we'll cover in the next program. But now let's run this and see. As you can see, we declared in 3 different forms and initialized with the same value, and you can see that being printed as same. And next, using make keyword. So make takes the syntax, make the data type that you're trying to make the object of, and in case of slice, the second variable will be the length, and the third variable will be the capacity. So what this means is slice as such cannot live on its own. It has to point to an underlying array. And in the previous example, when we created a slice directly, it creates an array with the same boundaries and initialize the value with the values that you have given, and just create a slice which is a pointer to that index, sorry, that array. So when you do create a slice using make keyword, it will create an array of the length 6 in this case, which is the capacity that you're giving, and create a slice pointing to the first 4 elements of that array. So yeah, so let's initialize the values and see. So I have initialized the first 4 values because that is the length of the slice that you have created. And similarly, you can use make with other forms of variable creation. Initialize and display the same line, inferring the data type, and then using shorthand notation. So the key point here is basically you have created a slice with the length of 4 and capacity 6. You can use other constructs like append to actually increase the length of the slice up till the capacity. If you try to increase the length of the slice using append beyond the capacity of the beyond the capacity of the slice, then it will have to create a new underlying array to match the required boundaries. So okay, let's give a run and see. So as you can see, I created a slice and did not initialize. You see it all being initialized to the 0 value of the data type of the element, in this case integer, which is 0. And then I have initialized individual element and then printed it. And this is the output for that. And these are different ways of doing it. I did not initialize, so it's all 0 valued. Next is slicing an array and creating a slice out of that. So like I said, slice literally means a slice of an existing array, and slice is just a pointer. So you can create a slice out of another slice, or you can create a slice out of another array. So in this case, I've created an array of 4 elements and initialized it with some values. And then here I'm creating a slice. So this notation basically what it does is create a slice out of another array or slice. Specifically in this case, I have the my array, which is an array, and I'm choosing the boundaries for the new slice as 1, which is which holds the value 10 in this case, and then up till 3, which is the end of the array. So this 0 is the 0th position, 10 is the first position, 2 is the second position, 3 is the third position. So what this ends up being is a slice with 2 values, which is 10 and 20. As you observed, the left-hand boundary is inclusive and right-hand boundary is exclusive, which is weird, but yeah, that's how it is. There must be some reason why they why Go authors decided to do it that way. So just to repeat, the left-hand boundary of the left-hand boundary is inclusive and the right-hand boundary is exclusive. So that means it includes in the new slice that we're creating, the index 1 is included and 2 is included, but not 3. When we run, we'll see that only the values printed are 10 and 20 in this case. Okay, so now both these boundaries are optional. What that means is if I skip the last right boundary, that is defaulted to the length of the array. So that is still the end of the array. And if I skip the left side of the boundary, it is defaulted to the zero index, which is the starting of the index. Let me run and see. As you can see, in the first case, I gave the boundaries as 1 column 3, which is, like I said, two elements, 10 and 20, and its length is 2, capacity is 3. I believe capacity is derived based on the starting position till the end. I'm guessing I could be wrong. And in the second example, the first element is the index 1, and second, I mean, the left boundary is index 1 and right boundary is till the end. So now we have 10, 20, and 30, and the length and capacity are 3 and 3. And the third example, I ignored the left boundary, which is defaulted to the starting of the index, starting of the array index, array slice, I mean, and the right boundary is 3. So in this case, the left boundary is 0, so it started with 0, 10, and 20, and did not include the right boundary. And as you see, the length is 3 because we have grabbed 3 elements, and the capacity is 4 because that is the total length starting from the left boundary, which is the beginning in this case. Okay, so we have other concepts with the slice, which is appending a slice to another slice, and like I said, slice is a pointer; it's not a value. So these two topics are for another video. I hope you enjoyed this video. Thank you very much.